If you are visiting our channel for the first time, please subscribe first to get the basic and advanced maths concepts. Today we will learn how you can find the derivative of inverse trigonometric functions that are in composite form. Now what does it mean? First of all, let's have a view on the already calculated derivatives of some inverse trigonometric functions. So these are the already calculated derivatives of inverse trigonometric function. But if you came across the functions where there are composite functions involving the trigonometric functions, then how you will be able to find their derivatives? One of the method is to find the derivatives of the composite functions by using the chain rule. This is the common method of finding the derivatives of composite functions, as we have already discussed that whenever you came across a composite function you have to use the chain rule. But how you will come to know that what is the composite function? Here we have another function. One function is this and another function is this. So we have two functions here. When there are two functions and they are in composite form, then you have to use the chain rule. But we also have the shortcut in other than chain rule to find the derivative. So we will learn that today, that how you can find the derivative without using the chain rule of inverse trigonometric function. So we will start with, as we have the function as y is equals to cot inverse of x over a. How you will find its derivative? Let's find. Dy by dx is equals to d by dx of cot inverse of x over a. Now what you have to do? You need not to use the chain rule here. You just need to do what? You have to find the derivative of this function first. So if we say that this function is the same as cot inverse of x, you have to consider the derivative of cot inverse of x currently. Then then we will move further. So cot inverse of x is where? Here we have cot inverse of x. So we'll write minus 1 divided by 1 plus x square. Here we have 1 plus x square because here it is x. So the derivative of cot inverse of x is minus 1 over 1 plus x square. Here we have x because we were having x here. But what if you have x over a here? What you will do? Then the derivative will be minus 1 divided by 1 plus x over a whole square. So keep this in mind that if you came across the function other than x, you have to take that function. So I'll write x over a whole square. Then what? Then you have to take d by dx of this function only, as there are two functions involved in this function. So as this is a composite function, so you have to find the derivative of both the function. So we have find the derivative of first, and now the derivative of second function you have to find. So dy by dx becomes minus 1 divided by 1 plus x square over a square, and the d by dx of x over a is 1 over a is constant and the derivative of x is 1. So just you have to write it like this. So the derivative is minus 1 over a square plus x square divided by a, as we have taken the LCM, dot a, and then this is a square. So this 1a will be cancelled with this, and the answer will be minus 1 divided by minus a divided by a square plus x square. So this is the derivative of the given function. By using a shortcut method, you need not to use the chain rule to find the derivative. So let's have one more example, little bit difficult for your convenience. Okay, another example is y is equals to secant inverse of 1 divided by x. Now how you will find its derivative? Let's find it by shortcut method rather than using the chain rule. So dy by dx is equals to d by dx of secant inverse 1 by x. Here again we have two functions. one function is, if I show you, this is one function and another function is this 1 by x. So you have two functions. So you have to find the derivative accordingly. So dy by dx is equals to, now what is the already calculated derivative of secant inverse of x? So secant inverse of x, d by dx of secant inverse of x is equals to 1 divided by x mod under root x square minus 1. So again note here that the already calculated derivative we have x here, but in this case we have 1 over x, so we have to replace 1 over x at all places. Like here you have to write 1 over x, here you have to write 1 over x. So I'll write the derivative as 1 divided by x and then under root 1 divided by x whole square minus 1, and then d by dx of what? This second function, that is 1 by x. So what we will get, dy by dx is equals to, x will go up, x divided by under root 1 minus x square divided by x square dot, what is the derivative of 1 over x? As x will move up, so it will become x raised to power minus 1, so it will be minus 1 divided by x square. This is the derivative of 1 over x. So if we further simplify it, we will get like this, minus 1 over x, and this will be cancelled like this, dot this x will go up, x into under root 1 minus x square, and this x will again like this, then we will get minus 1 divided by 1 minus x square. So this is the derivative of the given trigonometric function by using a shortcut method rather than using a chain rule. So that's all from today's lecture about how you can find the derivative of inverse trigonometric functions by using a shortcut method. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.